Hi. Are you interested in the question who or what is Pewdiepie? Well, let's find out. Okay, so this is a Mathematica tutorial in which we are going to investigate some of the most basic machine learning tools that they have implemented in Mathematica 11. Alright, so first of all, what I did is I selected one of these photos in this list of Google images searching for this term, Pewdiepie. Alright, so then I put one of those images in the documents folder of my computer. Alright, I'm running a Windows PC. Okay, so the first thing I want to write is A equals import, and then I've called my image PDP for Pewdiepie. Alright, so import, and then I had called it PDP, and that was a JPEG file, so .jpg. Alright, now I'm going to press Shift Enter, and let's see what we get. Well, I have one image of Mr. Pewdiepie. Okay, now that I have that, well, what can we do with this image once we have this image in the memory of Mathematica? Alright, well, you can do a lot of things. You can extract the image data and analyze the pixels. Alright, if you want to learn how to do that, well, have a look at one of my other videos. I've done this a couple of times at least. Okay, so I'm going to put the semicolon on there so we don't need to see his face. Alright, now I want to classify. Alright, so I'm going to write below image data A. Remember, A is that photo. And then oh, sorry, I want to write image identify, not image data. Image data is for pulling out the pixels. Okay, so image identify A, and we are going to specify a goal. All right, so put specify. This is an option. Specificity goal. Notice how the beginning of each word is uppercase. All right, now I put the minus sign and the greater than sign, and I'll press a space. That turns into an arrow, and then I'm going to say low. All right, L-O-W. Specificity. Okay, so that's why it was orange color there, because I didn't spell specificity correctly. Okay, now that we have this, Shift and Enter, and we'll find out what Pewdiepie is. Well, this says that Pewdiepie is an animal. All right, so in the kingdom, that's right, if I remember my biology, animal is the kingdom, right? And then there's plants, and then there's fungi. All right, so this says that Pewdiepie fits into the category of animal. Now let's go a little bit more precisely, and we'll say hi. Shift Enter, person. Okay, Pewdiepie apparently is a person. All right, now this is in orange. Okay, so I can then program with this and ask for more specific information. But let's have a look at comparing who this person might be. All right, so next I'm going to write B equals classify, and then classify among the category of notable people. So I'll write notable person. All right, and then what I'm applying that to this image A. All right, so next I will put A. All right, Shift Enter. Now this will take a little while. Well, Pewdiepie is apparently Robert Pattinson. Okay, well, if you don't know who Robert Pattinson is, well, then you can write, let's see, person data. person data. What do we want? B, what's that object? B, and then I want to grab an image of Robert Pattinson. Image. Okay, shift enter. And we wait. And we wait. Okay, so this has classified Pewdiepie as Robert Pattinson, and this is the image of Robert Pattinson. Now, what about if, I mean, clearly they're not the same person, right? So are there any other options? Well, you can ask Mathematica to decide the top probabilities. Okay, so next we'll write in brackets because I want to take 3 of them. So, and then in the first element, I'll write the string top probabilities. Okay, hopefully I spelled that correctly. Shift enter. Top notable person A up. It's hard to see whether or not I've spelled something correctly. All right, so I'm going to copy and paste and try that again. All right, now it works. So I probably misspelled probabilities. So this gives a probability of who Mathematica thinks that Pewdiepie is most like among the notable people. So the top probability being Robert Pattinson, the second probability being Ewan McGregor at 0.29, roughly a 29% chance, I suppose. And lastly, Josh Hutcherson. Okay, so let's find out. I see the problem here. So what we need to do, you see how this gave back an array. All right, so if I say I want to extract the second element of that array, which will be this one, Ewan McGregor goes to 0.29518. Right, but what I want to pull out now is the first one, which will be just Ewan McGregor. Right, you can do indexing on more abstract things than just arrays. All right, so I can pull out the first one there, which is Ewan McGregor. All right, we'll try that again. Shift enter, and we'll wait. Okay, so now here is an image on the Wolfram server of Ewan McGregor. Okay, and you can compare whether or not these two are actually similar. So yeah, they are. The hair color is quite similar, right? Just looking at these pictures from Google Images, hair color similar, and often he's wearing a dark color. So he was in this image A, as in Pewdiepie was wearing a dark color. All right, and they're both whitish pink color in the face. All right, sure. Let's try the third one. Josh Hutcherson, who I have never heard of. So the first element of that, shift enter. All right, so this guy looks like Harry Potter. Okay, anyway, sure. All right, so that's pretty interesting. Now, what else can you do with Mathematica's built-in machine learning functions? Well, you can do quite a lot, but to make full use of that, you need to go into the help file and see what they've provided for you, right? You can build your own classifier. You can apply it to some data and do some statistics and a lot of other things. But here's just another option. So if we write classify and we write, so I'm classifying in the category of sentiment, and I want to say what is the sentiment of this expression. It is very hot. All right, in Queensland, Australia, it's very hot. It's like I think today is meant to be 31 degrees centigrade, right, which is hot. Shift enter. All right, so apparently that's a positive sentiment. I would disagree if you're in the middle of summer. Okay, so, but if you are in the United States and suffering the cold winter, you might like this. All right, let's try another one. I am angry. Negative. Okay. Now, I am useful. Negative. All right, so it's not always perfect. I guess it takes a lot of research to get these things right. Okay, I am useful should be a positive one. What about I am useless? Negative. Okay, that's correct. Sure, so there's quite a lot of interesting things that you can do with this new capability in Mathematica 11, the machine learning tools. But there's much more than what I've done. So anyway, I hope you learned something from this, and I'll see you next time. Bye.